Hi. So today let's continue with our intersection of sets. Today we're going to discuss about the properties of intersection of sets. Okay. So first property is let me choose another color, say green. So first let's discuss about this first property, which is commutative property. So what does commutative mean actually? So by commute, what I mean is moving around. Okay, so look at this example. A intersection B is equal to B intersection A. Let's take an example. Let's take two sets. A is equal to 1, 5, 7, 9 and 10. Let's take another set which is B, which is equal to 5, 7, 6, 2 and 9. Now, as we learnt in the other video of intersection of sets, A intersection A, let me rub this off, yeah. So A intersection B gives me the common elements which are there in both set A and B. So intersection is basically, it forms a common elements set. So the common elements in both of these A and B sets are 5, 7 and 9, right? So now you can see that if A intersection B, since 5, 7 and 9 are the common elements, the commutative property holds very true for it. It states that if A intersection B is always equal to B intersection A. Okay, so we can see this above example and verify whether A intersection B is equal to B intersection A. So if we do a reverse of B intersection A, we will get 5, 7, 9 as the common elements. So commutative property holds true for intersection. Second, associative property. Associative property, when I say associate means grouping basically. Associate is nothing but grouping. So whenever you group a particular sets, then when you make a group of elements or sets, you form an associative property. Okay. Now A intersection of B intersection C. Okay, so let's give it another set. Okay, let's give another set which is C, which is equal to, and let's verify if it is right or wrong. Okay, so I will take 5, 11, 1 and 2, and let's verify if first, according to DMAS, we need to first do the things in the bracket. So since we have grouped it, because we are trying to verify the associative property, B intersection A, in B intersection A, let's take another color so that I am clear. B intersection C. Let's see B intersection C. We have got, so I will be writing it over here. B intersection C is equal to, what is the common elements that we find here? which is 5, right? 5 is the common element over here. Is there any other common? No. So it is a singleton set which is getting returned. So intersection B intersection C is returning element 5. Okay, a set. And now we have to now look at A intersection 5. So let's look at that. So we have a set A and we are trying to intersect it with another set which is B intersect C, which is 5. So now let's find out what is the intersect we get. So if I do A intersect C, I am getting 5 and 1. Okay, so sorry, I am getting only 5, right? Because we don't have 1 and it's a singleton element. So 5 is the only one. Since it's singleton, we have 5, right? So we are done with the left hand side, the LHS. We have got LHS. Now look at RHS. I'll change the color so that we know the difference. I'll take it as blue. And now look at this one. Now we have, so let's rub this off and just remember that we have got the LHS as a singleton set, which is we have A intersection B intersection C, which is equal to a singleton set, which is 5. Okay, and now this is the LHS, and now we are trying to prove the RHS. Let's take another color which we thought we would. Now look at A intersection B, this is a grouped element, intersection C. Now look at A intersection B. A intersection B is giving us, we know it's giving us these common elements 5, 7 and 9, which is intersecting with C, which will give us set 5, since 5 is the common element in A intersection B and set C, right? So you can see that this RHS, now this is RHS in blue, which is equal to the LHS. So we have proved that even the associative property is also holds true for intersection of sets. So let's go to the third point. So now let's take the third point and we'll choose another color for that. Let's take purple rather. Okay, now we are looking at this third point. It states that A intersection B is a subset of A. The set formed by A intersection C is a subset of A. Let's find out. A intersection C is, we have common, what are the common elements in them? We have 1 and we have 5, right? Is there any other common element in both of them? 1, okay, nothing. So we have a set which is having two elements, 1 and 5. Let's see if it is a subset of A. Subset of A. A, here is A. So 1 and 5, yes. So A intersection C is a subset of A, which is also true. You can see from here 1 and 5 are, so we understand by subset is if all the elements of a particular set are present in another set. So in this case we have a set which is of A intersection C and we have another set which is A. So we can find that 1 and 5 are both present both present in set A. That's why even the third point holds true, right? The third point holds true. And let's look at, so the same will be the case for A intersection B, the subset of B. Let's do that also. Let me rub this off again. So you can take your own examples and try doing it. So you will be able to clearly understand, and it will kind of be a practice for you to consider some sets and do the intersection, do the subsetting on your own. Okay, so let's take the third point, which is the second part of the third point, which is A intersection B. Now we already have these elements over here. A intersection B is a set which is a 5 elements or 3 elements, so 5, 7 and 9, right? So here we have 5, 7 and 9, and now let's find out if it is a subset of B. So see, the A intersection B has got 3 elements, 5, 7 and 9, which are also present in set B. So A intersection B is definitely a subset of B. So by definition, all the elements of this set are there present in the set B. That's why it is a true statement. Okay, this is also a true statement, right? Now what I want you to do is take the examples or the sets I have given here, okay, and I want you to put down in the comment section whether this and the 4th, 5th and 6th points hold true or not. Okay, so let this be an exercise for you. Revert back if there are any queries. I hope intersection of sets is quite clear to you, because this is intersection is basically when you have two sets and you have a common elements in both the sets. That is the intersection point. Okay, so let's move on to union of sets in our next video.